Black holes. The very term conjures up images of the unknown, the unfathomable, and the incredibly powerful. Just the name evokes a sense of mystery and wonder. These enigmatic entities have fascinated scientists and stargazers alike for generations. Imagine a place where gravity is king, so strong that nothing, not even light, can escape its grasp. This is the realm of the black hole, a region of space where the rules of physics as we know them cease to apply. These cosmic objects are among the most fascinating and extreme entities in the universe. They challenge our understanding of the cosmos and push the boundaries of what we know about space and time. For centuries, black holes lived only in the realm of theoretical physics, as predicted by Einstein's theory of general relativity. These predictions were based on mathematical equations and thought experiments, far removed from any tangible evidence. But now, thanks to advancements in telescopes and imaging techniques, we have visual evidence of their existence. The Event Horizon Telescope, for instance, has provided us with the first ever image of a black hole, a groundbreaking achievement in the field of astronomy. We've even captured images of the supermassive black hole at the center of our own Milky Way galaxy. This colossal entity, known as Sagittarius A*, has a mass millions of times that of our Sun. But what would happen if you were to get too close to a black hole? The intense gravitational pull would create a scenario unlike anything else in the universe. Would you be crushed into oblivion, stretched like spaghetti, or perhaps transported to another dimension? The concept of spaghettification, where objects are stretched and torn apart by gravitational forces, is one of the many mind-bending phenomena associated with black holes. Let's embark on a thrilling thought experiment, a journey into the heart of a black hole, to explore the science and the mysteries that lie within. As we venture deeper, we'll uncover the secrets of these cosmic giants and ponder the ultimate question: what lies beyond the event horizon? To understand a black hole, imagine the most extreme vacuum cleaner you can, a cosmic vacuum cleaner. This vacuum cleaner doesn't just suck up dust and debris, it pulls in everything around it with an almost unimaginable force. It's like a giant cosmic whirlpool, drawing in anything that comes too close. But unlike a regular vacuum cleaner, a black hole's pull is so strong that not even light, the fastest thing in the universe, can escape once it gets too close. Black holes are regions in spacetime where gravity is so strong that nothing can escape, not even light. Imagine spacetime as a fabric, and a black hole as a heavy object placed on this fabric, creating a deep well. Anything that comes too close to this well gets pulled in, unable to climb back out. This is why black holes are often depicted as dark voids in space, because they trap everything, including light. They are formed when massive stars collapse at the end of their life cycle. When a star has exhausted its nuclear fuel, it can no longer support itself against the force of gravity. The outer layers of the star may explode in a supernova, but the core collapses inward, creating a black hole. This process is one of the most violent and energetic events in the universe. Picture a star much larger than our Sun, running out of fuel and collapsing under its own gravity. The star's core becomes incredibly dense, and its gravitational pull intensifies. This collapse happens so rapidly and with such force that it creates a singularity, a point of infinite density at the center of the black hole. This collapse squeezes the star's core, creating an object so dense and with such immense gravitational pull that it warps the fabric of space-time itself. The gravitational field becomes so strong that it bends light and distorts time, creating a region where the normal rules of physics no longer apply. This warping creates a region around the collapsed star called the event horizon. The event horizon is the boundary beyond which nothing can escape the black hole's gravitational pull. It's like a one-way door. Once you pass through it, there's no turning back. Think of the event horizon as the point of no return. It's the edge of the black hole, the last place where you can still escape if you have enough speed. But once you cross this boundary, you're inevitably drawn into the black hole's core. Once you cross it, there's no coming back. The gravitational forces inside the event horizon are so extreme that they stretch and compress anything that falls in, a process known as spaghettification. This means that anything, whether it's a star, a planet, or even a spaceship, would be stretched into long, thin shapes as it gets pulled toward the singularity. The gravitational pull inside the event horizon is so strong that even light, the fastest thing in the universe, cannot escape. This is why black holes appear black. They absorb all the light that comes near them, making them invisible against the backdrop of space. The only way we can detect them is by observing the effects of their gravity on nearby stars and gas clouds. As you approach a black hole, you wouldn't initially feel anything different. Gravity, after all, is the same everywhere. However, things get strange as you get closer to the event horizon. One of the first things you'd notice is the distortion of light. The immense gravity of the black hole bends the path of light rays passing nearby, creating a visual effect called gravitational lensing. Stars behind the black hole would appear to be in different positions than they actually are. Time itself would also behave differently. As you get closer to the event horizon, time would slow down for you relative to someone observing from a safe distance. This phenomenon, known as time dilation, is a direct consequence of Einstein's theory of general relativity. Now, for the not-so-fun part. As you venture closer to the black hole, the difference in gravitational pull between your head and your feet would become increasingly significant. This difference in gravity, known as tidal force, would stretch your body like spaghetti. Hence, the term spaghettification. Imagine being pulled from your head and feet simultaneously, your body stretching thinner and thinner like a strand of spaghetti. It wouldn't be a pleasant experience, to say the least. The tidal forces near a black hole are so extreme that they would rip apart not just your body, but even the atoms that make you up. Section 5. Beyond the veil, inside a black hole. What lies beyond the event horizon? That remains one of the biggest mysteries in astrophysics. Our current understanding of physics breaks down at the singularity, the point of infinite density at the center of a black hole. Some theories suggest that you might not even notice crossing the event horizon. You'd continue falling towards the singularity, experiencing increasingly distorted space and time along the way. Others propose that the singularity might be a gateway to other universes or dimensions. Perhaps black holes are cosmic portals connecting different parts of our universe or even different universes altogether. Section 6. A bridge through space and time? Wormholes and white holes. Speaking of portals, let's talk about wormholes. Wormholes are hypothetical tunnels that connect two different points in space-time. Imagine folding a piece of paper in half and poking a hole through it. That hole is a two-dimensional representation of a wormhole. If wormholes exist, they could provide shortcuts for traveling vast distances across the universe or even time travel. Some theories suggest that black holes might be one end of a wormhole, with the other end being a white hole. Unlike black holes, which suck everything in, white holes are hypothetical regions of space-time, where nothing can enter, and everything inside is ejected outwards. They are like the reverse of a black hole. Section 7. Could you survive? Peeking into the unknown. So, could you survive a black hole adventure? The short answer is unfortunately no, not in the way we understand survival at least. The extreme tidal forces, time dilation, and the singularity itself make it highly unlikely that any living organism could withstand a trip into a black hole. However, the laws of physics as we know them break down at the singularity. What happens inside a black hole remains a mystery. Perhaps there are aspects of black holes that we haven't even begun to imagine, possibilities beyond our current understanding of physics. Section 8. Back to the Future, Emerging from a Black Hole. Emerging from a black hole is another mind-boggling concept. Imagine the sheer force and gravity that a black hole exerts, pulling everything into its dark abyss. The idea that something could emerge from this cosmic trap is both fascinating and perplexing. Remember that nothing, not even light, can escape the event horizon? This boundary marks the point of no return, where the gravitational pull becomes so strong that escape is impossible. This escape problem is one of the biggest challenges to understanding what might happen inside a black hole. Scientists and physicists have long debated the mysteries that lie beyond this enigmatic boundary. Some theories speculate that information that falls into a black hole might not be lost forever. This idea challenges our understanding of physics and the nature of the universe. Instead, it could be encoded in some way at the event horizon, like a cosmic hologram. This concept suggests that the information is preserved in a two-dimensional form, even as it appears to be lost in three-dimensional space. This information paradox is a topic of ongoing research and debate among physicists. The implications of solving this paradox could revolutionize our understanding of the universe. If we could somehow retrieve this information, it would be like looking back in time, offering us a glimpse into the history of everything that has ever fallen into the black hole. The Event Horizon preserves a record of everything that has ever fallen into the black hole. This cosmic archive could hold the secrets to understanding the very fabric of space and time. Section 9. Conclusion. The universe's enigmatic heart. Black holes are among the most enigmatic objects in the universe, pushing the boundaries of our understanding of physics and reality itself. They are cosmic laboratories where gravity reigns supreme, distorting space and time in ways we are only beginning to comprehend. While a black hole adventure might not be feasible in the traditional sense, the exploration of these celestial objects continues to captivate our imaginations and inspire scientific inquiry. As we delve deeper into the mysteries of black holes, we unravel more about the universe's origins, its evolution, and perhaps even our own place within its grand cosmic tapestry.